If you want to master organic chemistry, welcome to Chemistry Not Mystery. You can also visit my website chemistrynotmystery.com. This is the second lecture on alkene. In this video, you will learn what are electrophile and nucleophile, how to identify electrophile and nucleophile, and how do electrophilic addition take place in alkene. First, try to understand the literal meaning of electrophile and nucleophile. Phile word is derived from philic, that means affinity or love. Electrophilic means electron loving. It has affinity for electrons. It must be electron deficient. Its general representation is E+. It can be positively charged species or it can be neutral but has incomplete octet like BH3 and AlCl3. Nucleophiles are nucleus loving species and has affinity for nucleus or positive charge. It must be electron rich. Its general representation is Nu-. It can be negatively charged or neutral but has lone pair of electrons like H2O and NH3. Let's try to identify electrophile and nucleophile. H+ is electron deficient, so it's an electrophile. Cl- is electron rich, that's why it's a nucleophile. OH- is nucleophile. BH3 is a Lewis acid, that's why it is an electrophile. I- is a nucleophile. H2O has lone pair of electrons, that's why it's a nucleophile. HSO4- is nucleophile. H- is also a nucleophile. Now try to separate electrophile and nucleophile in a given molecule. H2O can be split into H+ and OH-. H+ is an electrophile and OH- will be the nucleophile. HCl can be split into H+ and Cl-. H+ is an electrophile while Cl- is a nucleophile. HBr can be split into H+ and Br-. H+ is an electrophile and Br- is a nucleophile. H2SO4 is an acid. You must know its structure S double bond O OH OH. When it splits into HSO4- and H+. H+ is an electrophile and HSO4- is a nucleophile. Now let's try to understand electrophilic addition reaction to an alkene. When an electrophile approaches pi bond, electron density shifts towards one of the sp2 carbon due to electromagnetic effect, and it develops a partial negative charge and forms a bond with an electrophile. The other sp2 carbon develops a positive charge to which nucleophile gets attached. In this reaction, carbocation is formed as an intermediate. Carbocation stability plays an important role in deciding the fate of the reaction. Tertiary carbocation is more stable than secondary, is more stable than primary, is more stable than methyl carbocation. Tertiary carbocation is the carbocation bonded with 3 other carbons directly. Secondary carbocation is bonded with 2 other carbons directly. Primary carbocation bonded with 1 other carbon directly, while CH3+ is the methyl carbocation. In tertiary carbocation, plus inductive effect of alkyl group and hyperconjugation donates electron density to carbocation and stabilizes it. while in methyl carbocation there is no such donating effects. That's why methyl carbocation is the most unstable carbocation. Now see the electrophilic addition to symmetric alkenes. When electrophile approaches to pi bond, electron density shifts towards either of the sp2 carbon and it develops a partial negative charge and forms a bond with the electrophile. The other sp2 carbon develops positive charge to which nucleophile gets attached. But if you do the electrophilic addition to an unsymmetric alkene like propene, it doesn't the same. Let's see, the electrophile approaches the pi bond, electron density shifts towards one of the sp2 carbon. Since both the carbons are not identical, there will be two cases. If left carbon develops the negative charge and gets attached to electrophile, nucleophile gets attached to the last carbon. In other case, if the right carbon develops the negative charge and gets attached to the electrophile, nucleophile gets attached to the middle carbon. So how do you decide which is the right one? Here secondary carbocation is formed while in other case primary carbocation is formed, and you know secondary carbocation is the more stable, that's why this will be your major product. Markovnikov gave a rule for the electrophilic addition to double bond and triple bond. According to that, negative part of the reagent goes to the carbon that has less number of hydrogen. Let's practice the rule. If you add HCl to propene, electrophile H plus gets attached to CH2 and nucleophile Cl minus will get attached to CH. If you add HBr to propene, electrophile H plus gets attached to CH2 and nucleophile Br minus get attached to CH. If you add Hi to propene, electrophile H plus gets attached to CH2 and nucleophile I minus will get attached to CH. If you add H2O to propene, electrophile H plus get attached to CH2 and nucleophile OH minus get attached to CH. If you add H2SO4 to propene, electrophile H plus gets attached to CH2 and nucleophile HSO4 minus will get attached to CH. If you remember the structure of HSO4 minus, you will know that it will get attached as OSO3H. In the next lesson, we will learn halogenation, hydroboration oxidation and anti-Markovnikov rule. To master organic chemistry, stay in tune with Chemistry Not Mystery, and don't forget to like and share this video. And if you have any doubt, you can post them in the comment box. And please subscribe to the channel. You can also join my Telegram channel. Thanks for watching. Keep learning. Stay safe.